Page 211, number 55. Use the properties of logarithms to expand the expression as a sum, difference, and or multiple of logarithms. And we're given the natural log of x to the fourth times the square root of y over z to the fifth. Okay, so we're going to have to use a number of different properties here. Let's take this thing a little bit at a time. First of all, we have the natural log of some quantity divided by another quantity. One of our properties tells us that we can write this as two separate logarithms subtracted. Here's what I mean by that. We've got the natural log of everything on top, x to the fourth times the square root of y, minus the natural log of everything on bottom, z to the fifth. Okay, so anytime we have a logarithm of two quantities divided, we can write it as two separate logarithms subtracted. Now let's take care of this part right here because we have the logarithm of two quantities multiplied, x to the fourth times the square root of y. Anytime we have the logarithms of two quantities multiplied, we can write that as two separate logarithms added together. So I can say that's equal to the natural logarithm of x to the fourth plus the natural logarithm of the square root of y, and then I'll bring down minus the natural logarithm of z to the fifth. Okay, now let's take care of these powers because we know that anytime we have the logarithm of a quantity to a power, I can write that power out in front. So I can say that's equal to 4 times the natural logarithm of x plus. Now this natural log of square root of square root of y is equal to y to the 1/2 power. Okay, and if I think of it that way, I can take the 1/2, move it out in front, so I can write this as plus 1/2 times the natural logarithm of y minus, last but not least, let's move this 5 out in front, 5 times the natural logarithm of z. And there's our answer, 4 natural log of x plus 1/2 natural log of y minus 5 times the natural logarithm of z.